Hi everyone, here are your section 8.5 notes. Today we're going to get into multiplying and dividing radical expressions. So the nice thing here with multiplying radical expressions as opposed to our adding and subtracting is I don't have to have the same radicand. I do need to have the same index though. So here we have a binomial times a binomial, and inside our binomial we have radical expressions. So 7 minus the square root of 3 times the square root of 5 plus the square root of 2. So we can just FOIL this, or double distribute, is what I like to call it. So I'm going to take that 7, I'm going to multiply it to the square root of 5, which would just be 7 square roots of 5. I don't have anything to multiply with that radical itself. Now I'm going to take that 7, I'm going to multiply it to the square root of 2, which is 7 square roots of 2. I can't combine those, right, because they don't have the same radicands. Now let's do the inside here. So that gets me square root of 3 times the square root of 5 is the square root of 15. And then here I'm going to get a negative square root of 6. I do have all like indexes, which is great, but I do not have any like radicands, so I can't add any of those together. So that is your answer. Right there. Done. All right, next example, we have the square root of 10 plus the square root of 3 times the square root of 10 minus the square root of 3. Now you should recognize this as a difference of squares, right? So if you guys remember back to your difference of squares, your middle terms will cancel out. But in case you don't remember that, let's go ahead and multiply through. So the square root of 10 times the square root of 10 is the square root of 100, which the square root of 100 is 10. Square root of 10 times the negative square root of 3 is negative the square root of 30. Here I get a positive square root of 30. And here the square root of 3 times the square root of 3 is the square root of 9, which is 3. A positive times a negative is a negative 3. So now when I combine my like terms, my two middles cancel, and I'm left with 10 minus 3, which is 7. Now keep that in the back of your brain for when we get to dividing. And we talk about conjugates. Here we have the square root of 7 minus 3 being squared. So again, that's just rewriting this twice, right? So the square root of 7 times the square root of 7 is 7. Square root of 7 times 3 is negative 3 square root 7. Here I get another negative 3 square root 7. And here I get a positive 9. Combining like terms here, my 7 and my 9 will combine to make 16. And if I have negative 3 square roots of 7, subtract 3 more, gives me negative 6 square roots of 7. If you guys kind of remember the shortcut that I guys when I showed you back when we were doing this with polynomials, to get your first term, square the first, which just cancels out the square root sign. To get your last, you square the last, which gets us the 9. Now how do I get the middle term? I multiply straight through. So 2 times negative 3 is negative 6 times root 7 is negative 6 square root 7. And then when I combine my 7 and my 9s together, that gets you to the 16. So if you kind of remember that, there that is. All right, so now let's change from a square root to a cube root. So things will change a little bit differently. In the last few examples, when we were doing the square root of 7 times the square root of 7, we were getting the square root of 49, which is 7. So whenever I have two of the same square roots, they cancel out and I'm left with the radicand. But that's not going to be true for cube roots, because cube roots is an index of 3. So I'm not going to cancel it out. So in order for it to cancel out, I need to have 3 of those 7s to get to 7, right? Because the cube root of 49, that doesn't simplify any further. It's just the cube root of 49. Let's keep that in your brain. So up here we have 5 minus the cube root of 3 times 5 plus the cube root of 3. So I do know my middle terms are probably going to cancel out here. Let's go ahead and multiply through. So 25 plus 5 cube roots of 3, then we get negative 5 cube roots of 3, and then on this last, I'm going to get a cube root of 3 times 3, which is 9, which is the cube root of 9. I can't simplify it, so just leave it. Middle terms cancel, so I'm left with 25 plus, oops, nope, minus, right, because it's positive and a negative, minus a cube root of 9, and that's our final answer. Okay, so a little less simplifying is needed here. Now let's just do variables. So again, notice we have a difference of squares. So k square root of k times the square root of k times the square root of k would go to just a k, because it's the square root of k squared, which is k. We get a minus square root of ky. Here we get a plus a square root of ky. Put your letters in alphabetical order. Here we get a minus y. So I'm just left with k minus y. All right, so now this gets us into dividing and what we call rationalizing denominators. So I don't know if you remember way back when we listed out steps for when a radical is completely simplified, and we said that we cannot have denominators with radicals in them. So I think we had a quiz where we ended up with a radical in the denominator, and some of you guys already did rationalize it, which made me a little curious on if you remember to do that from last year, or did you copy it from PhotoMath? I don't know. So we're going to go through it now. So it is improper practice to leave a radical in your denominator. So what you can do is you can use the identity property of multiplication and multiply by a smart number 1, because I can multiply anything by 1 and it won't change it. It keeps it the same. But the number 1 isn't always just necessarily the number 1. The number 1 could also be 4 over 4, or 5 over 5, or x over x, right? All of those things would simplify to 1. So if I have a square root of 7 in my denominator, I need to think about what can I multiply? Like, what can I multiply that square root of 7 here by to be left with something without a radical? Well, if I multiply a square root of 7 by itself, then I'm just left with 7, right? Because the square root of 7 times the square root of 7 is the square root of 49, which is 7. What I must do to the bottom, I must do to the top. So multiplying my numerator leaves me with 3 square roots of 7. So that is the same exact fraction. I didn't change anything. I just rewrote it so that I did not have a square root sign in the denominator. That's called rationalizing the denominator. So from this point on, if you are left with a radical in your denominator, you are going to be expected to rationalize it. Okay, so for this one, I have a square root of 5 in my denominator. So I'm going to multiply by a square root of 5 in both the top and the bottom, because it's just a 1. That's just 1. And I can multiply anything by 1, right? So my denominator leaves me with just a 5, but now my numerator, I have a square root of 2 in the original, so I'm going to combine these together to make a square root of 10, and then bring that 5 here. So I can now simplify that. Ignore the square root of 10 right now, and just focus on the number without the radical. I have 5 in the top, 5 in the bottom, so I can cancel out those 5s and be left with just the square root of 10. I do not want to simplify your radicand by whatever is in your denominator. Do not do that. Do not do that. Okay. Ooh, next one. We have -6 all over the square root of 12. So we've got 2 options on what we could do. We could just multiply by the square root of 12 on the top and the bottom right away, and then simplify later. Or we can simplify first and then, or simplify first and then multiply by the radical. I'm going to go with the second option, just because then I can multiply by smaller numbers. So let's go ahead and simplify that square root of 12. So that would be 4 times 3, so that would go to 2 square roots of 3. So I have a -6 all over 2 square roots of 3. Now again, ignore the radical for now. Can I simplify what's there? Yes, I can. -6 over 2 is -3. So this becomes -3 over the square root of 3. So that's much more simplified than the original. So now I can rationalize my denominator by multiplying by a square root of 3 on the top and the bottom, which gets me -3 square roots of 3 all over 3. Now ignore your radical. Don't touch it. Leave it as is. What's going to simplify? Well, my 3's can cancel, and I'm just left with a negative square root of 3. I could have gotten there by simplifying later. So let me just show you second version. You can just watch. If I were to multiply by a square root of 12, top and bottom, wouldn't be too terrible in this case because 12 is not that large of a number. Then I end up with negative 6 square roots of 12 all over 12. And then I can take out a 6 here, take out a 6 here, which leaves me with negative square root of 12 over 2. And then simplifying that square root of 12, well, that's 4 and 3, so that goes to negative 2 square roots of 3 all over 2. Cancel them out, leaves you with your negative square root of 3. So you can get there both ways. It's kind of up to your personal preference. All right, so let's try this one. We have negative square root of 18 over 125. So I can separate this to the square root of 18. I'll put the negative in the numerator just for fun. Over the square root of 125. Factors of 18, so 9 and 2. So it's going to go to negative 3 square roots of 2. Don't forget that negative. 125 is 25 times 5. So that would go to 5 square roots of 5. Does anything cancel out? No, it does not. So now I'm going to rationalize my denominator. I am only going to multiply by the radical, which in this case is a square root of 5. So now in my denominator, the square root of 5 times the square root of 5 is a 5. But then I need to multiply those two together to get 25. In my numerator, bringing those together gets us the square root of 10, so negative 3 square roots of 10. If I ignore the radical for now, can I reduce anything out of negative 3 and 25? No, I can't. So I'm done. There's my answer. In its most simplified form. All right, here we have a square root of 50 m to the 4th all over p to the 5th. So I'm going to simplify my 50. So that's 25 and 2. So 5, and I'm left with the square root of 2. I purposely left a blank there because I have to deal with my variable of m. The square root of m to the 4th, that is just m squared, right? And now let's go down to the bottom. Square root of p to the 5th. Well, how many sets of 2 go into 4? 2. How many left over? 1. Okay, so ignoring radicals, can anything simplify in front? Unfortunately, no. Oops, my p kind of went away. So now I'm going to rationalize. I'm going to multiply by a square root of p, top and bottom. So now what am I left with in my denominator? Well, square root of p times the square root of p is p. And then I got to multiply these together. So p squared times p is p to the 3rd is what I am left with in my denominator. In my numerator, I'm going to multiply these together. And then I am left with 5m squared square root of 2p. Answer. Ooh, cube roots. Let's do some cube root work. Okay, so cube roots is where it gets a little bit more confusing. It's not as easy as just multiply by the radical. Because if you guys remember back when I said the cube root of 7 times the cube root of 7 is the cube root of 49. So I'm still left with a radical. I need 3 cube roots of 7 in order to be left with a 7, right? Okay, so kind of keep that in your, so if my index is 3, I need a set of 3. If my index is 4, I need a set of 4. If my index is 2, then I need a set of 2. Okay, so let's go ahead and simplify these. I have a cube root of 27 over the cube root of 16. Well, 27 is a perfect cube, that's 3. Cube root of 16 is not. That simplifies to 8 times 2, because remember my perfect cubes are 8, 27, 64. So the cube root of 8 is 2, and we're left with a cube root of 2. So that's in my denominator. So 2 cube roots of 2. So now, to rationalize my denominator here, I currently have 1, 2 in my radicand, but my index is 3. So that means I need 3 sets of 2s. Or not 3 sets, I need 3 to my set, right? So here's 1, here's 2, here's your 3rd. So because I have that, that would then cancel all of that out. So these all together would just make a 2. Does everybody see that? Because it would be the cube root of 8, which is 2. Now I'm going to multiply these together. So now I'm going to have 2 times 2, so 4 in my denominator. Now I have to do the same thing to the top. So I multiplied by cube root of 2 times 2, which I don't have any cube roots to combine with there. So I just am left with 3 cube roots of 2 times 2, which is 4. Do not simplify this radicand with that 4. They don't cancel each other out. Okay. All right. Fourth root. Let's do a fourth root one. So here we have the fourth root of 5x all over z. So again, I'm going to separate this. Fourth root of 5 over x over the fourth root of z. Can't simplify any of those. So now my index is 4. So to rationalize my denominator, I currently have 1z. So how many more do I need? I need 1, 2, 3 to get 4. So then when I combine all that together, I'm just left with a z in my denominator. What I do to the bottom, I must do to the top. So z, 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 which is just z to the third, right? When I multiply these guys together, I'm left with a fourth root of 5x z to the third, all over z. Okay, so you need as many of as your index, okay? All right, so now this is going to lead us into what's called a conjugate. So if you guys remember way back in the beginning of these notes, when we were multiplying by something like x plus y and x minus y, the middle terms canceled out and we were just left with the first and the last. So whenever you have the same terms but different operations, so a plus and a minus in between those two terms, those are called conjugates. So x plus y and x minus y are considered conjugates of each other. So in order to rationalize a denominator that has like a binomial in it, all the ones that we were doing so far had monomials in the denominator, we have to multiply by the conjugate. So right now I have a 4 minus the square root of 3 in the denominator. So if I multiply by the conjugate, which is 4 plus the square root of 3, in both the numerator and the denominator, I'm going to be left with no more radicals in the denominator, which is what I want. So when I multiply this out, I get 4 times 4, which is 16. My middle terms are going to cancel out, so I'm not even going to go there. And then my last is the square root of 9, which is 3. So 16 minus 3 is 13. So my denominator now turns into a 13 when I multiply by the conjugate. Now I have to multiply the numerator through. So multiply, 5 times 4 is 20, 5 times the square root of 3 is 5 square roots of 3. So I'm going to rewrite that over here. So 20 plus 5 square roots of 3. So now if I ignore my radical, is there any number that I can take out of 20, 5, and 13? There isn't. If there was a number that I could take out of all three of them at the same time, then I would and simplify it out, but I can't in this case. So that is your final answer. So here we have the square root of 2 minus the square root of 3 all over the square root of 5 plus the square root of 3. So again, not proper practice to have radicals in your denominator. So let's go ahead and multiply by the conjugate, which would be the square root of 5 minus the square root of 3. What I do to the bottom, I must do to the top. So now let's multiply my bottom through. I'm going to ignore the middle terms. I mean, if you are in the habit of not multiplying and foiling correctly, maybe you should FOIL everything. But since I am multiplying by a conjugate, the middles are going to cancel. So my first, root 5 times root 5 is 5. Root 3 times negative root 3 would be minus 3. So it looks like I'm getting a 2 in my denominator. Up here, root 2 times root 5 is root 10. Here I do need to make sure I multiply everything because nothing's going to cancel. I get a minus root 6. I get a minus root 15. And I get a plus 3. So is there anything that has like radicands? Nope. So I'm just going to rewrite. I'm going to put my 3 in front. So 3 plus the square root of 10 minus the square root of 6 minus the square root of 15. If I ignore my radicals and just look at the numbers that are left, can I simplify anything out of 3 and 2? No. So that's my final answer. Done. Here we have 3 over the square root of 5m minus the square root of p. So again, my conjugate would be the square root of 5m plus the square root of p. What I do to the bottom, I must do to the top. So in my bottom, I'm going to get 5m minus p. In my top, I'm going to get 3 square roots of 5m plus 3 square roots of p. Can't simplify any of that, can't combine anything, so that's my answer. Okay, so multiplying by conjugates. So let's really quickly go through and make sure we can simplify in lowest terms. And all of these, I didn't have to simplify them. So if you did end up multiplying through with your conjugate and you were left with something like this, can you simplify it? So if I ignore that radical and look at my 3 numbers there of 6, 2, and 4, what can I divide out of all those numbers? Well, I can divide out a 2, I can divide out a 2, I can divide out a 2, right? So if I divide out a 2 from everywhere, then I'm left with 3 plus the square root of 5 all over 2. So that would be simplified in lowest terms. So that's what that would look like if you had to do that. Okay, so if we look at this one, let's say you multiplied through in your conjugate and this is what you were left with. So we have 5y minus the square root of 8y squared all over 6y. So we can simplify a square root of 8. That's 4 and 2. So that would go to minus 2. I can simplify the square root of y squared, which is y, and I'm left with the square root of 2. And then we have a 5y all over 6y. So again, you ignore the radical. Just kind of think of that as a variable. And what can I take out? Well, I can take out a y everywhere. I can't take out a number. So now I'm left with 5 minus 2. What was that, a square root of 2? All over 6. And that would be your simplified in lowest terms, right? Your simplified form. Okay, that concludes your notes, everyone.